Hello, you're listening to episode number 19 of the IoT Weekly podcast. Hello and welcome to episode number 19 of the IoT Weekly podcast brought to you by Gearforge Software. My name is Matthew and I'm joined by my co-hosts Cliff and Zeineb. Hi guys, how are you doing?
Hi.
Cheerio, Matthew. Doing well.
Cheerio again.
It seems to be a good day today.
It is a good day.
It's sunny.
Very cold, just very Minnesota-like.
It's bracing.
Yeah, we went back to winter. We're going backwards here. Spring is supposed to be strong.
No.
Exactly. So, guys, we've got an exciting episode today.
I can't wait.
I know, yeah, it's fantastic. Instead of news, we're pleased to welcome David Ewing from Firia Labs, who's going to fill us in on their exciting IoT project. So, Cliff, what have you been up to lately?
Well, after finally getting you to read the book, I actually went and seen the movie Ready Player One. Absolutely loved it. Even though it is quite a bit different than the book. I won't do any spoilers.
Yeah, no spoilers.
And I believe it took the box office this last weekend.
Did it?
Yep, it was #1 in the box office. And I spent some time playing with a microbit, leveraging code space from Firia Labs. So I got my son to work with me on it, and I've got one of them that he programmed sitting right next to me, and I was showing Zeineb just a bit ago about it.
Yeah, it makes all the smiley faces and hearts pretty exciting.
Very cool. Yeah, I've heard only good things about the microbit, so
Yep.
I've never had a chance to play with one, though.
Yeah.
So, Zeineb, how about you? What have you been up to?
So I finally finished the Arduino project, and
Awesome.
I got a bit carried away, and I tried to learn Happy Birthday on it. And my coworker next to me, she just looked at me like yeah, it was bad. It was an obnoxious buzzer piano. I mean, after you get to wash it away, and so got to watch a band last night, and that was really, really fun. So
It sounds fun.
yeah, I mean, I should have brought my buzzer piano, just got on stage.
Exactly.
Yeah. Well, what about you, Matthew? What have you been up to?
Sandwiches.
Sandwiches?
Yeah, I had a really hard time thinking of anything interesting to talk about this week. But I think the thing that popped into my head was we've been on a sandwich kick at my house, all three of us. So my wife and myself and our almost 12-year-old son, have been eating sandwiches for dinner every night. And so we pull out all the fixins and everybody makes their special sandwich. Yeah, so that's been kind of fun.
That is so
I mean,
fun.
before this, it used to be soups. Do we need to send you sandwich recipes now?
I'm open to sandwich recipes for sure. You know what? Here's the thing. I've been really into specifically capers. You guys know what capers are?
Seriously? Capers?
Those are
Yeah.
good.
Yeah, I got a little jar of capers and I've been putting those on my sandwiches and I'm just so tickled about that.
Oh my gosh, that's so funny. I don't put any capers on my sandwich. Huh.
You should
I didn't
start.
know they had capers in
Really?
this country. I guess they
Believe
do.
it or not, yeah, they do, and you pretty much buy them next to the pickles. So
Oh,
The pickles. I love it.
Right. Yeah, so that's the most exciting thing going on right now. Sandwich.
But there's not much to do. It's like, I don't know. It is currently way too cold. Like 17 degrees and sunny, and we got almost a foot of snow over the last 3 days. So
Yeah,
with more snow coming.
we had to call the yard service that they come and blow out the sprinklers or whatever in the spring. We had to call them and say, well, the entire yard is still under a foot of snow. We better postpone it.
We get a letter from our mosquito spraying company saying we're going to be holding off for a little bit yet.
Exactly. Welcome to Minnesota.
I know.
So do we have any feedback this week?
We actually do. So we had a posting saying that the GDPR goes in effect at the end of May. And it affects IoT businesses not only in the European Union, but potentially everywhere in the world. And so the GDPR is a General Data Protection Regulation, and it's pretty broad and very strict when it comes to data. So we had somebody actually tweeted back, Alex, and said, "Hey, I'll listen in. Curious to know what, if any, impact this will have in the U.S. From what I've heard so far, not much." So really appreciate that, Alex, and that was on Twitter.
Yeah,
Yep.
and I am not an expert, and I don't play one on TV.
No?
But what I
What about,
know,
you play one on a podcast at all?
well, sometimes. But as far as the GDPR goes, so this is basically data privacy, big data privacy law that is going into effect in the European Union, and it basically puts guarantees in place, consistent guarantees across the member countries as to how companies deal with their data. And I think, not a lawyer either, but I think if you don't do business in those countries, right, I'm not sure what the effect of that is. If you do business in those countries, like I'm thinking about Microsoft right now,
Mhm.
Yep.
then this is a huge deal, I would assume, right? But it's interesting. What if you have, I wonder what happens if you have users,
Mhm.
right, who have logged in or they've signed up for your service, whatever it is, and they happen to live in the European Union.
Then you probably need to stick to the same very strict standards, and so I mean, I understand Alex like kind of doesn't, he's saying that it might or might not impact the US, but I really do see this like being a big blow to Google and
Big
companies
companies,
Well,
with
and I think
using
it's,
extremist data basically.
here's the piece that I was interested in. It's like, what is the data that they're concerned about? And so here's, according to the European Commission, personal data is any information relating to an individual, whether it relates to his or her private, professional, or public life. It can be anything from a name, a home address, a photo, holy buckets, an email address, bank details, posts on social networking websites, medical information, or a computer's IP address. That's crazy, Matthew, because I mean, think about a normal form you fill out on a website. It
Yep.
typically has your name, email address, potentially your phone number, and it typically tracks your IP address.
Mm-hmm.
And this regulation says, hey, it applies to organizations based outside the EU if they collect or process personal data of individuals located inside the EU.
Right. That was kind of the point I was getting to there was just because you're in the United States doesn't necessarily mean that it doesn't affect your company. I mean, I think, I think I said like doing business in an EU country, but what about I have a website and I'm collecting, contact form type information, and somebody happens to submit.
Like
yeah, it sounds, again, not a lawyer, but kind of sounds like it's far-reaching, and I don't know how that works out in terms of U.S.-based company or a company based somewhere else in the world, not in the EU. But yeah, it's certainly interesting, something we need to watch.
Yeah, it's pretty. This is crazy. I mean, it's pretty in depth here. I'm looking at the Wikipedia article, and it's just, I'm like, holy buckets.
Well, it's interesting. This is one of the things that Satya Nadella, the CEO of Microsoft, I read his book a few months ago, and this is one of the things he calls out as being particularly difficult, is trying to follow all of the various laws in different countries. And he said basically it's impossible for a big company like Microsoft to be consistently, following all of the various laws related to data and privacy in all of the countries where they do business at the same time, and still maintaining a product. So
yeah, I can't imagine. Yeah, so this is definitely, we'll have to keep an eye on this. I think it definitely can have an impact on the IoT arena. because I mean, golly, there's a ton of personal stuff that's flowing through and inattentional or unintentional, I should say. So if you have feedback on this, please let us know at our podcast, or not our podcast, our Twitter. It's at Gearforge IoT, or you can shoot us a message at podcast at gearforgesoftware.com if you have some thoughts on this. We'd love to hear back from you. Or if you just have a sandwich recipe you'd like to share with Matthew, please do.
Yeah, if you enjoy capers on your sandwiches, I would love to hear from you.
Yeah.
So, Zeineb, do you want to share our show sponsor?
Oh yeah. So I mean, we know it's the IoT Fuse Conference of 2018. They've been our sponsor for a while. Thanks, guys. And so the IoT Fuse Conference 2018 is the 4th edition of the conference, and it's trying to unite accomplished doers, makers, and hackers with the brightest executives, entrepreneurs, and innovators, so tech and business. And they're trying to bring together a robust community of IoT practitioners, developers, and makers who want to build a deeper understanding of where IoT is today, where it's headed in the future, and how the associated technologies and use cases can improve the physical world in which we live. They are still selling tickets, although it is not early bird pricing anymore. So you could check out the pricing on the website if you want to get your tickets. Check out the workshops, see what works for you. And we have one. We have a workshop, right?
We do.
We do. Could you tell us a little bit about it?
So go ahead, Matthew, if you want to.
Sure. So our workshop is practical IoT machine learning, not just for data scientists. Our concept here is, in IoT, there are tons and tons of sensors, and it's basically all about sending sensor data to the cloud, but that seems like sort of the bread and butter, right? That's what every IoT project does. What we were kind of interested in looking at was, if you are not, maybe you work for a company that doesn't have, let's say, a dedicated data team or a dedicated data science team, but yet you're collecting all of this data, and it doesn't have to be IoT data, but since we're focused on that realm, that's kind of our use case. We're talking about sensor data, but without having that dedicated data science team, what can you do with this data, right? And we want to show how you can use some sort of cloud machine learning technologies to do some really cool things with it. And this is a great place for you to basically learn more about that basic machine learning. And we're really kind of aiming at not just engineers, but our thought here is, if you know what a CSV file is, if you can work with a spreadsheet, you'll probably be just fine in this talk. So
that's our goal, is to really make it accessible. I think that's part of the problem with data science. It's really scary sounding, and people start thinking algorithms right off the bat. Yeah,
well, it's a whole realm of deep knowledge, right?
It is.
But in this case, we're going to leverage other people's brains who have put this out basically in the cloud for us to leverage, and it's surprisingly easy to make something useful out of it.
Yep, that's our goal, how to make it easy.
Yeah, and I think if I can do it, anyone can do it.
Excellent. All right, well, I guess guys, it's probably time for our main segment.
Oh, it's so exciting.
Yeah. We are pleased to welcome a special guest today, David Ewing, who is president and co-founder of Firia Labs. Firia Labs has an exciting educational product called CodeSpace. It's really cool. It's based on using the BBC microbit and also Chromebooks, and it's aimed at educational markets. So we'll dive into those details here in a minute. David, welcome to the show.
Hi, thanks a lot. Glad to be here.
Yeah, well, I think it would be great if we could get started, if you would just share a little bit about yourself, and we'll kind of get into the company also.
Okay, sounds good. Yeah, so so probably much like yourselves, I grew up with a love of technology, taking stuff apart. And, it started with walkie-talkies, little toys, and trying to figure out how these things work, messing with electronics. And, dating myself a bit, it was back in the days when desktop PCs had 8-bit CPUs. So anyway, back in those days. So fast forwarding to the IoT, it's like retro. You can grab a little system on chip and hey, this is like what I used to have on my desk.
Right.
But anyway, so that led me into learning the assembly language and messing around with stuff like that. And it's back in those days, I was thinking, there's nothing really that does a great job of teaching kids about electronics, about this sort of software and that sort of thing. And of course, through the years, at the time I thought, one day maybe I'll write a book about that if I ever figure all this stuff out, So I wound up as an electrical engineer learning a lot about a lot of that stuff. And thinking back to those days, hey, nobody needs to write a book about that stuff anymore, right? We've got the internet and the maker movement and everything. And there's all this information out there for kids to be able to figure this stuff out. But really, when I started looking at what was going on in schools and my own kids going through and learning things, as it turns out, at least in K through 12 schools, there's still not a lot of great resources that are aimed at teaching this sort of thing. They're getting there, but not as quickly as I would like to see. So that's part of the motivation behind what we're doing at Firia Labs, and we'll talk about that in a bit. But through those years, I guess I found myself in, made my way to Huntsville, Alabama, doing for NASA, doing some work on Space Lab, and then a number of tech startups since then, and the commercial sector. The last one being an IoT company. Of course, 10 years ago when we started it, I think we called it machine-to-machine communication, not
right,
IoT.
it was different,
yeah. It's different, But it definitely was. The company prior to that, I was working on big, telecom equipment where we had, 64-bit processors and gigs of RAM in these quote embedded systems, and
right.
And then all of a sudden I'm in a world where I think the first processor in the IoT company we had, it was a Freescale 9SO8. It's a little 8-bitter with 4K of RAM, and indeed it was that retro experience. Like, this is so cool. People still use 8-bit controllers,
Yeah.
And
yeah.
of course now. But mostly it's ARM processors now, but they're still small and neat and really cool. And it's something that I truly love. Sort of I'm sort of mixing in and out of the story about teaching kids, because that's really what I want to talk about Firia Labs. But as I try to get my own children to kind of get interested in programming computers a little bit, or hardware or software, they really look at it a lot differently than I did, of course, because they've got, PS3s and Xboxes and stuff at home, so making something happen on the screen is just not as impressive as it was when I was a lad. And in fact, if you do, any of the online, there's plenty of great online, systems to learn coding. Most of them, you're not creating Skyrim or PUBG. I mean, if you're a gamer or something like that, it's like, yeah, I can't do anything that's really all that impressive on the screen. But little IoT things, little boards with LEDs and maybe a servo motor hooked up to it and stuff like that, maybe that would be a bit more engaging. And so that's kind of the theory, and a hypothesis going into this education space. And so we set out to see if we could prove out that hypothesis.
There's kind of the physical component to IoT I feel like it brings it into I hesitate to say this, but brings it into the real world in a way that showing something on a screen doesn't, right?
Yeah, I think it's a thing, and it's one of those interesting, sociological aspects of what we do. Watching how different students respond, and in fact, it does make it more tangible, obviously, literally, more something you can reach out and touch. And it's not that you can't solve extremely important problems on the screen, but I think a lot of the way that coding has been presented to a lot of kids, it didn't seem that important. You know, they're not trying to do something that really relates to something they could make, I don't know, a cool thing, a project that would be actually desirable and cool. Didn't seem to materialize on the screen so much. It was like, well, this is a game, but it's not a really cool game. It's just, you've made this game yourself, so isn't that great? And some kids are like, that's so awesome. These are the geeky kids like me, you know, the ones who are going to get into it anyway.
Right.
But we're trying to get a much wider spectrum of kids involved in the technology business, right? But, you know, importantly, girls. You know, we need more girls and you know, other underrepresented groups. And so really part of what I'm trying to dial in on here is, you know, what does it take to make a wider swath of people interested in this? And in fact, I'm talking to a lot of the educators and people who know a lot more about, you know, the pedagogy and the science of education than I do. They've really kind of revealed some of these things. You know, we were showing a demo of NeoPixels lighting up, you know, up and down the little strip, and with the microbit and some MicroPython code that we're using, super easy to make to control NeoPixels, and those are really awesome. One of the teachers looked at it and said, you know, most of the boys would think that's just great. You guys have there's little LEDs up and down, and seeing how that worked would you know, that would float their boat, you know. But girls are probably going to go, well, why? What's it actually for? What does it do? And I sat back and was like, wow, you're right. You know, we don't need to build projects that just light the lights up for no good reason. We need to have each project have a motivation behind it and a relationship to the real world. And so that's really one of the things we've tried to craft in our product.
I think that's really interesting. You know, this is probably a good lead in to talking about actually, you know, what brought you to found Firia Labs and sort of create this thing and create the product here.
Right. So, so it was a couple of years ago, and we had been running Synapse Wireless for about 10 years. I've been there for about 10 years since we, you know, helped start the company. And I was the CTO of that company, had a great team. We built lots of different IoT projects. You know, we basically were selling, among other things, a set of wireless modules that had our own special mesh networking software, as well as a Python virtual machine that we developed. So we actually could remotely program all these things in Python.
Cool.
And for a long time, the desire had been brewing to do something in the educational space, and it just wasn't something that lined up with the business model of Synapse. So that was a big motivator to go out and do this. And then the other half of it, you know, our company Firia is actually an IoT consultancy, and you guys are familiar with how that works. And we, you know, the team that I had and that we have assembled here at Firia just has a lot of experience building out, you know, IoT hardware and software systems in lots of different industries. So that was it was nice because it could help us fund the educational arm of the company, the product arm of the company. And one more little piece that's important is we at the time that I left Synapse, I started writing up a SBIR grant submission, and we did win an SBIR grant to fund the development of the first bit to this. So it was a great, you know, I give a plug out to the seed fund that NSF and other SBIR sponsors represent.
Yeah, that's great. And I saw that on your website.
Yeah.
And so for kind of getting, you know, it's interesting that you've got the consultancy side of the business and now you've got this sort of educational side. Could you explain maybe just, I want you to paint me a little bit of a picture of how does this play out in, let's say, like an educational environment, a classroom? Do you come in? How does it work to get these devices in the hands of kids, get them using the platform, working with the educators themselves? I'm just trying to get a picture here.
Yeah. So we ran a pretty intensive beta program since starting in January. So it's really January through the end of March. So we've just really launched the product here about 2 weeks ago for general use. So this is a good timing to be chatting about it.
Yeah.
And part of that process really started before January was talking to interviewing a ton of teachers, doing that customer discovery process, you know, finding out what are the problems that they're seeing, and then trying not to lead the witness, right? We wanted to understand what they needed. One of the things, and we had no idea if the hardware would be amenable, or interesting to them, or what problems they were facing. So that shaped how the product is delivered right now. They wanted something in general that was a solution in a box, a kit. And so we provide the product as a kit with the classroom size pack is 10 microbits. So we ended up leveraging this hardware, awesome little board that was produced and designed in England, the BBC microbit. It was a part of a program about a year ago that they rolled out to all I think they call it 7th year students, which is around 6th, 7th grade age over here, so that they could teach coding on this little platform. Once we saw that platform, when we were doing our interview cycles, we saw that microbit platform was starting to enter the U.S. So those boards are available in the U.S. and it's low cost. It connects over USB. There's a lot of things we liked about it. We that was a bit of a pivot point, because up to that point we had our own little single board, Wi-Fi enabled, also IoT-like little robot guy. Neat because it moves around and stuff, and we thought it had the minimal amount of sort of engagement factor that you could build lots and lots of coding curriculum around it. So really focus on the coding, not on the putting together Lego bricks or the hardware bits of it.
Right.
So anyway, so we came into that interview process, and based on what we saw, we sort of pivoted towards, let's leverage the microbit. Let's put a lot more emphasis on making the software really easy to use and making it so that it's really a self-guided curriculum. And so that's the other piece of it that's really important. If a teacher buys one of these kits, we don't have to go out there and give them a lot of training. It's very, very easy to use in terms of, from the very first step, we don't assume you know any coding at all, and it starts you with your first little couple of lines of Python code. One of the things we found from our interview process was when we interviewed teachers who had tried to teach Python in the past, and which is a very popular language, all the way around, but it's popular for education as well. And the biggest problem we heard from them about teaching Python was that kids would get stuck. And when the program didn't work, it just flat didn't work a lot of times. They would just sit there staring at this, unintelligible looking code. So the hands would go up, and the teachers would, walk over and say, well, what were you trying to do? And if you've ever looked at someone else's code,
yes.
especially when you're just getting started, even if you know what you're doing, it takes a little while to figure out, what are you trying? I don't quite see what you're trying to do here, right? And so, but the teachers, almost every teacher we interviewed, even the ones in high school that were teaching CS, the first thing they'd tell you is, look, I don't have a CS background. I am a math teacher. And they thought because I was a math teacher, I could do this computer science stuff. So let me just tell you right out of the gate, I didn't go to school for this, and the text-based code is really beyond me. I don't think I'm ready for that, And it's very intimidating in general to a lot of teachers, and for good reason. It's like a foreign language. And so what we saw a lot was they had kind of reverted back to drag and drop block-based approaches, which I think were very good systems for introducing concepts of code. And certainly through, first, second, third grade, those are great. But we've seen fourth graders just rock and roll on the Python stuff, So certainly taking that drag and drop approach into middle school doesn't seem to make sense. And I think it's only being done because the teachers they don't have anything that helps them be comfortable with text-based.
Sure. Yeah. And you specifically mentioned, this product it's focused on teaching text-based programming, not drag and drop, which I think is interesting. And you're right. A lot of the sort of intro to programming, I'm thinking about like Scratch and development tools are definitely visual sort of drag and drop tools, right?
Right.
And so you're kind of taking this in a different direction. What is it about the text-based approach that you think is so important?
Well, so first I'll say the blocks, here's what you get from the blocks. It's a constraint, which is actually, in a lot of ways, a good constraint. It eliminates big classes of problems that you might have.
Sure.
And sort of syntax errors and things like that. So that makes it easier to get something working, and less of a burden to remember things or to be able to type something out. So those are definitely some advantages. But because you don't make those mistakes, you also don't learn from those mistakes. So it's blocks, and we asked a lot of questions without, trying not to lead anyone, with what our hypothesis was. We asked a lot of educators questions about how the transition went from blocks to text-based, and did it seem, if a student had had a lot of exposure to blocks, were they really at a big advantage to ones that didn't when it came to learning something like Java or C or whatever the next language was, Python, whatever. And by and large, what we found out was, no, not really. That it doesn't seem to really ease that transition all that much. There's a lot of things that they get tripped up on. And so it's, I think as an intro to the concepts of how computers work, the blocks do certainly have a place. And so we're not trying to set ourselves up to be, anti-Scratch or block-based programming. I think it does have a place. But what we found was there's a gap. And it's really manifested in, you start seeing nowadays, a lot of high schools are starting to have makerspaces. Librarians are being challenged to have the makerspace in the library. And when we were kids, it wasn't the library either. It was a media center. You remember that?
Yeah.
Oh, yeah.
Now
yeah.
So now it's progressed even further. But so librarians are also ill-equipped to tell you anything about how to program that Arduino or the Raspberry Pi. What do you actually do with that? And it's only a tiny percentage, sort of the same as when I was a lad, of kids who were that nerding out on it that much. And what we'd like to see is a lot more kids do it. So we wondered, where you have a lot of kids that can have some success with Scratch and block-based programming, and then they kind of fall into this gap. And out the other side, by the time they're in 9th or 10th grade, you'd hope they'd be, hacking on the C code, and they're not, or there's very few that are. And so a lot of them lose interest. And I think part of the reason is what we've seen in our observations here is blocks. First of all, if you have a block-based program and you try to make it, you can make complicated programs, and they can get really big and gnarly, and they're really hard to understand. So they lack the abstraction ability of text. They're not as rich and expressive as text-based coding. Otherwise, heck, we'd be using text-based, or we'd be using blocks to write phone apps and everything, right?
Right. Yeah.
So and it's been tried for years, man. I mean, 40 years ago there were block-based things, and of course, you got a few success stories. National Instruments makes a good, good thing with LabVIEW and all that stuff. But by and large, the text wins out in terms of being able to simplify things and be more expressive. And another analogy sometimes I'll use, and I'm not sure if it's totally appropriate, is in kindergarten you have picture books, right? I mean, because maybe the text is a little too abstract, but then pretty soon, by the time they're in 1st or 2nd grade, you're kind of almost going cold turkey off of the picture book. It's like, no, you're gonna have to learn words and sentences and stuff. And if you're trying to encourage more of your populace to be literate and to write novels and things like that, right? If you kept them all in picture books up through middle school, you're not going to probably inspire very many literary, greats. I mean, I think that's part of it. I want people to fall in love with code and have a passion for doing this. And I just don't think you're going to get as passionate if you're stuck with the drag and drop stuff for too long.
Well, and David, I think I can, because you were kind enough to just send over one of these labs. And so, I've got a 13-year-old son. And so I've tried to get him into Arduino, and even into Google had a kit that we put together for their home kit, and it used a Raspberry Pi, and typically he was able to help with the electronic side, but once we got into the code, it was just too much. And the funny thing is we had started with Scratch Junior a long time ago, and it was funny because I think it was 4th grade, his teacher had no idea what this was. He showed it to her. She liked it, but he ended up teaching the class how to use Scratch Junior and going over to the other class and teaching them, because I'd forced him to do every single thing. He hated me at that point.
Yeah.
But I was like, when you went through everything, then we'll move up. And then we started on some code camp. But I've really struggled with some of the embedded with him, just because it's just too much. And so I was like, well, let's see if this works. So I had him crack it open Wednesday, and I got to tell you, we went through CodeSpace, and I had him do everything, David. I helped a little bit. He killed it, absolutely killed it.
Awesome.
I think we I thought he was going to stop. He worked until it was almost 9:30 at night. Usually he's heads to bed about 9 o'clock. He didn't want to stop. He finished up with, I think, he got through lesson 5. And he's like, you know what we could do, Dad? I'm like, what? And he goes, we could make a Magic the Gathering counter based off of this last program we wrote.
Yes. That's beautiful.
So he was already thinking
and
ahead.
Yeah, and you know that you hit on a very, very key part about this, and you sent a couple of questions ahead of time. What do we mean by open-ended when we talk about this is open-ended? You know,
yeah,
and that's exactly what we're talking about. You know, even 4th, 5th grade students, younger than our initial sort of target for the product, once they start working with it, they start seeing that they could do anything they wanted to with this. It's there's the GPIO pins are brought out, and I mean you can control anything with it. And so what we built, another thing that we kind of saw when I started looking at what was out there, my team started looking at what was out there on the market for teaching coding, and even the Arduino stuff, which is great, it didn't seem, it's more suited to hobbyists and people who already are self-motivated to just slog it out and figure stuff out versus
not a kid
who may or may not, you may lose them, I mean, kids may not, and especially if they're like, think about a kid who people are telling them this is maybe not cool or not for them, or like I'm a girl or I'm somebody that doesn't show up on TV as a programmer, So you're not going to give it a whole lot of, time if it's not speaking to you or if you're not having success with it.
Well, and I think you're spot on with having the device. Like, he was thrilled when he see the smiley face show up on the 5x5. And he's like, I did this. And he points at the code and he's like, oh my gosh, I like, you could see it light up on his face. Because you were saying earlier, like using the embedded coupled with the code. And it just, I think that's the kicker right there. Yeah.
Well, and as IoT folks, we understand the thrill of some of that, It's the reason, like, after the first project that we have them do something kind of significant, we say, unplug it from your computer, put the battery pack on it, and check it out. Play the game you wrote, click the buttons. And because I want to make sure all the kids know, wait, this is running on AAA batteries. I could put this on my skateboard. I want them to start thinking, I wrote code for this little computer. This is not connected to the internet, this is its own thing. And so, that's very powerful. And we were happy, I was half expecting that to be wrong, that hypothesis from the beginning. I thought, well, maybe it's just me. I love these little things, let's see how just general kids, of all stripes, react to it. And teachers too, what do they think about it? Does it still seem scary even after they've started seeing their class have some success with it? And the teachers have loved it, and they've been. It's been really a great thing to see that as well. That they can learn right alongside their students. They don't have to feel like they already know how to code before they start into it.
That's awesome.
That is so cool. Hey, David, could you describe sort of the software side of CodeSpace a little bit more?
Sure. Yeah. So there's actually some really great technology all through it, and so I'll start. I'm going to pick up my little microbit and hold it in my hand so I can start from the bottom up. And I'm going to describe this from the. I know you guys speak to a lot of people who are interested in IoT, so I'm going to describe it as an IoT system, the bottom up, right? So the code that the kids are writing runs on a little Nordic NRF51 part. It's a system on chip, got 16K RAM, 128K flash. It's running something called MicroPython, which is an open source project, an implementation of Python 3 for microcontrollers. So really cool. The code that you write actually is running interpreted, running on a Python virtual machine on the little Nordic part, which has Bluetooth radio, so you can actually send packets across, and the microbits can talk to one another. And we've got projects in the works that are coming online that make use of that capability.
Yeah, that's pretty cool.
So what we've done to extend MicroPython is we've added a really, really critical missing piece from Arduino and all the educational products that I've seen out there for text-based coding, which is a debugger. So we've added this capability into that MicroPython code on the Nordic part to be able to single-step debug, view your variables. So you can, if a lot of the teachers were telling us, when their kids get stuck, if there's a logic error or something, well, even the teacher can't really help them out. They're like, what do you do? It just doesn't work and it's a blank screen. So this lets them actually help themselves out of a jam. You know, if it doesn't work, we say, well, step into it and see what's happening. You know.
Well, that is such a critical thing too. I mean, my mouth like opened when you said that, because you know, that's one of the sort of fundamental skills that engineers learn, right? Is how do you help yourself solve this problem? Right.
But it's even worse though on a embedded though. Those are just brutal trying to do some of those.
Yeah, well, you feel like you're sort of, you know, it's in a black box and you can't see inside of it. But in reality, you can if you think about the problem properly. Like, how would you solve that? Right? It's just with a debugging tool right there. I love that that's sort of the critical feature. Teaching kids about debugging is amazing.
Yep, and you know, again, back to the kind of the interviews, as we interviewed different teachers at different levels, I would listen to see, do they ever, I'd say, well, what do you do when there's a problem in the code? And I'd listen to see, are they ever going to say, well, we use a debugger? And some of them use things like robot C and some other, there's different languages out there being used for education. And there's only, out of a bunch of interviews, maybe one or two even mentioned the term. And then when I would drill into it, they're like, well, those are kind of for advanced users. And I'm like, you know, actually, if you're in a classroom and no one, including the teacher, really knows how do you know, with you or I, you know, we might just get pencil and paper and like step through very carefully. And we're basically emulating the computer in our mind, right? And we're keeping track of what the values of all the variables are. And we understand what we're doing. We're going to slow through it. But they don't understand how to do. They've never been taught how the computer even works in the first place. So if we just we demo to them, you know, we have little videos built into the code and stuff that says, here's how you step into the code, and it's going to walk down one step at a time. And if you've got a branch, it's going to show you taking that branch. You know, hold down the push button and hit step so that, you know, when it reads the input pin, it's going to step into that branch. And so it's a way of teaching, you know, how the computer thinks. And as well as just diagnosing problems. So we thought that was going to be a really
and I can tell you that was huge for my son. He loved that, and I was like, "Why do you like this so much?" Because he is like just playing with it. Like it was a toy all of a sudden, just playing with the debug portion. So it just cracks me up, David.
Awesome. Well, let me take. I'll continue. I promise to go up the chain real quick. So there's the Nordic part. Also on the microbit, there's another processor which is an NXP MKL26 part that's really just part of the ARM embed system. Okay, so it's running that embed deal where it controls the USB port, and if you drag and drop a hex file over to the microbit, it will flash it into the Nordic part. So that's what that little guy is, and that's by default on the microbit as it ships from England, you know, from their original design. What we've added, and it also has a USB serial port functionality, so you can get the REPL for Python. You can have a command line on the Python code by default. What we added was
that's great.
Yeah, good. But the problem is that requires a special driver, and you know you have to install a driver. What we found out from teachers was they're not generally allowed to install drivers in their computers. The IT department controls that. The ones that had software, usually it was out of date by 2 or 3 years, and they said, you know, they can't really, it's difficult to update. So there's all these problems with, you know, how are we going to have the ability to let teachers install USB drivers so that we can hook into the USB serial port so that we can actually have real-time access to do something like a debugger. This is a bad problem, you know? So the solution, I'll fast forward to the solution, was back in September, the Google Chrome and Chromium open source team, in all their wisdom and brilliance, came up with this thing called WebUSB, or they launched it into product. It's been around for a year or so. WebUSB is the future of USB drivers. It's your USB drivers in JavaScript. And if your embedded device supports WebUSB, you plug it in and Chrome just goes, bing, I see this USB device. Do you want to connect to it? You know, so no driver required. And if you want to update the driver, well, it's on the web. You know, it happens automatically from the web page that you're on. So we implemented WebUSB inside that NXP chip, so that then when we plug in with a Chrome browser, either running on a PC, Mac, or even a Chromebook, which we found through our research into schools that there's a ton of Chromebooks out there, and they're low cost. You know, for a couple $100 you can get a pretty nice Chromebook, and they stay up to date. You know, a lot of the other laptops that we found and systems we found in schools were running, God forbid, Windows 7. And not that there's anything wrong with that. It's been 8 years, people. They're unfortunately out of date in a lot of ways. And so the Chromebooks movement also made us very confident about embracing WebUSB. And then sort of moving up the stack, we hosted we've got a cloud backend that integrates with Google Drive. So when you write your code, it just gets saved to your Google Drive account, which is nice. You can log in with Google and do all that. The front end, is of course, JavaScript based, but it gives you that real-time debugger. It's got that real-time WebUSB connection to the hardware, so you can do that single stepping, refreshing variable values. Downloading your code is really fast, so the edit, run, debug cycle is really fast. And in the existing sort of state of the art, currently, people that are using microbits out there in the world mostly use drag and drop. There's a drag and drop environment called MakeCode that Microsoft sponsored as part of this BBC microbit effort in the UK, and it's block based. And what it does is it generates a hex file that then the kids drag and drop that hex file onto their microbits, which takes a little while for them to wait for it to load, and then they can run their stuff on the microbit. So it's not real time. It also doesn't show you, like in Python, you get runtime error messages and things. And in our system, those pop up, and we highlight the line of code that the problem is on. Whereas if you're using the drag and drop hex file method, they don't establish a serial connection at all to the hardware. So with something like MakeCode, so we really, I think, have upped the game significantly in terms of being able to have a really fun, user-friendly coding environment.
Yeah, that's awesome. What a cool concept.
Well, thanks. We think so.
Yeah, I think it's just terrific. And Chromebooks it's like ubiquitous in schools now. My son's school, they had Chromebooks throughout his elementary school, right? And his primary machine now is also a Chromebook. So it's a terrific fit with this this concept. I love it.
Great. Yep. We've been really happy with them, and I didn't have anything against Chromebooks to start out with, but I wasn't sure, how much of an advantage it was, or if they had some drawbacks. And from what I've seen in the classroom, I've only seen advantages from them. They've, every single Chromebook we've tried our product on, it's just worked. And we're using very modern web technologies, not just WebUSB, but some other things that you need a modern web browser. If there's been any incompatibility issues, it's always been on some other machine that has, that wasn't allowed to be updated for some reason. Yeah.
Right. Yeah, it's one of the nice things. The Chromebook is, in its way, sort of a controlled environment, right? Because as you mentioned,
right,
they're always updated. It runs only the Chrome browser. Like they're just sort of assumptions you can make about the environment. It's all Linux under the hood. So you figure sort of there's a consistency happening there. So yeah. I think it's really smart. I love it. So this seems like just a terrific product. I love kind of your mission and your vision here. Were there any other things that you wanted to sort of talk about today about CodeSpace, or sort of where you want to take this product?
Well, I think we've covered most of it. I do want to, I'll mention that we do plan on adding not only lots of additional projects. We've got 6 additional projects in the works. So hang in there. Once you finish I think there's 10 solid projects in what you've been playing with. There's 6 more that are coming within the next couple of weeks. So including using the radio with you've got two modules there. So even our small kit has 2 modules. So you can do, all the cool things like finding out, does the light in the refrigerator really turn off? So
that's awesome.
We get that photo cell. Yeah, those are important experiments, that you need to do. And as an IoT person, you of course have to also do the experiment where you find out when you close the microwave door, and this is a 2.4 gigahertz radio, can you still get a signal out?
Yeah.
And the answer,
nice.
The answer will scare you. Just don't turn the microwave on, but
right.
But yeah, you'll get a solid signal out of there.
That's so fun.
That's
so anyway,
awesome.
but yeah, we have other, I mentioned we had designed a little Wi-Fi based robot product that also ran MicroPython. So it uses kind of the same programming model. And we thought, this could be this, our original intent was, heck, a lot of schools can only afford one or two at the most of these, like, Lego robots. They cost $350. And a classroom full of 25 kids, how many of them are really going to learn to code if you've got one platform and 25 kids sharing it? Not many, because, as we know, coding is kind of a one-on-one sport in a way. You have to make your own mistakes and learn, and then share with your buddies and learn more. So we built this little robot platform that we could build for less than $50. Had a micro on it, had the motors and everything, and would do plenty to do, line following and maze tracking and all kinds of cool stuff. At some point, we are going to roll that out, and it'll be underneath this sort of code space environment. So we'll have more projects. We plan on having more accessories for microbits as well. So, we've got a lot. There's so much you can do with it, and I think there's so much need for that sort of thing. That's what we have in mind. And the only other thing I would just ask, hey, help us get the word out if you can. We're still a super small voice in the world of ed tech, and we're finding out that it's a little bit hard to get recognized out there. So I think we've got something really awesome, but our biggest risk maybe is that no one will really ever find out about it.
So
absolutely.
Yeah. So question, David, then. So if, let's say, myself or some of our listeners would love to be able to, like, at least introduce this to maybe teachers, because I know at my kid's school, he's got a teacher that she does all the current coding type stuff. If I wanted to introduce her, what's the best way to go about that, David?
Yeah, well, first of all, you can certainly have her reach out to us. You can email info@firialabs.com, and we will have a human, one of our happy Mary team will get in touch with you and just answer any questions. We've got a couple of kits on the website that you could just, hey, buy a kit or try. If you already have a microbit, or you can pick up a microbit, online. They're available stock. You can actually try our platform for free. So we have a free tier of the product. It doesn't have all the debug features, but it does have a great experience in terms of being able to load code onto the microbit, being able to real-time see error messages and things like that. So we try to provide, even at the free tier, a really good taste of what the product can do. And so those are some ways you can give it a shot.
Well, that's great. Excellent.
Awesome.
Yes, and absolutely, we will do everything we can to get the word out.
Yes, I think this is just an amazing product.
Yeah, super cool. Also, I wanted to thank you for helping to raise the next generation of coders using Python. When I was a kid, I mean, my first programming language was AppleSoft Basic, which also dates me, by the way, with the line numbers and everything,
Oh yeah.
But I think it's really exciting. I mean, the growth of Python, the popularity of Python in general, has been kind of staggering over the last few years. But it's really a great language, and I think it's a great first language. So it's kind of exciting to think there's going to be a generation of coders raised on Python.
Yeah, I agree with you. And I also started with Basic long ago, same sort of deal, line numbers and everything. And I learned Python actually over the years because I had a nephew who was 10 years old, and he was wanting to get into programming. And I thought, well, certainly Basic is not the language to teach somebody that's trying to learn programming. So I looked around, and so I'm like, okay, well, what is the Basic of today? What would you use? And so that's when sort of Python popped up on my radar. And this was a long time ago. This is probably 15 years ago at least. But then I learned Python in order to teach it to a kid, but then I used it over and over in industry. And, while I'm not a language zealot, I do think it's among the best languages, if not the best language to teach a first-time programmer. And just as a general purpose language to know, it's a great language to know. The only contender, might be, in my mind, JavaScript. As based on its popularity, it's just everywhere, but I honestly can't, and we could go, that'd be a whole nother episode. We could talk about it.
Absolutely.
I code a lot of JavaScript, a lot of the stuff you see in your code space, it's got JavaScript behind it. So we know it well. And, but yeah, Python, no worries at all. It absolutely is a wonderful language for teaching as well as stuff.
It's funny, David. Cliff and I had that exact same conversation just this morning about JavaScript or Python as a first language.
Well, and the funny part of this, David, is that my son now, he's like, where can I get a book on Python, Dad? Because he, after going through these tutorials, he's like, I want to learn more about this. He just loved it.
Yeah,
Maybe
great.
you do need to write your book after all.
Yeah, but I'd be curious with like Python for kids or something like that couples with code space. That would be really cool.
That's a good idea, actually. I felt like that once we got into the curriculum part of it and the lessons, it very much was like writing a book. You're trying to make it engaging and entertaining, but at the same time trying to be succinct, not be too verbose, but then also explain. It's really that's a tough challenge. So a great sympathy for authors of textbooks and things right now. But we'll continue and work hard at doing that, and hopefully get lots and lots more material for kids to dig into.
Well, and please reach out when your new lessons come out. We'll give a quick blurb here on the podcast and let folks know as much as we can, David.
Absolutely. And hey, thanks to you guys for having me on. Really appreciate it.
Well, it's been our pleasure. Thanks so much for joining us.
Yes, we're very grateful. Thank you.
And we would like to once again thank David Ewing from Firia Labs for joining us today on the podcast. And if you have any feedback for David or would like to ask any questions that we just didn't think of, you can get in touch with us at podcast@gearforgesoftware.com or on Twitter. We're at Gearforge IoT, and we'd love to hear from you.
Most definitely.
Yep.
All right. Well, that just about wraps things up for this week's episode. Do you guys have anything fun planned? Cliff, how about you?
Well, since it is really cold outside, my typical scenarios this time of year would be wanting to get outside, get in the yard, and clean things up. But again, with the snow covering the ground, I'm going to be inside all weekend, so and all week. So we've got a full week and weekend worth of stuff coming up here. I think I'm going to play with Microsoft's machine learning platform. I've been playing a lot with Amazon's, and it's a lot of fun. And take a crack at Microsoft. I had it open a while before, and I'm going to play with theirs a bit more.
Well, that sounds great.
Mm-hmm.
So Zeineb, how about you?
So a friend of mine has taken their car back, and before they do that, they let me, after I insisted, to use my spray chalk that I got on Easter on the car. So tonight we're gonna go to the parking lot. He's gonna have to be there because there's surveillance cameras everywhere. But it's gonna be a lot of fun, just making sure everyone knows it's legal.
They have spray chalk?
Yes, I was impressed. I just have it. It's blue. It's weird. I'm totally going for it.
You should spray some snow too, see if it sticks.
Oh, that might
be would.
that I'll go for it.
I'm just kind of curious to see if it does it just turn blue? Does it soak in, or I don't know.
I think it would soak in a little bit, but you know what? Maybe I should do it and
just
see.
A quick blast.
Zeineb, I have questions.
Yes.
Have you tried spray chalking a car before?
Absolutely not.
Are you certain that's not gonna? Yeah, go ahead, Matthew.
Yeah. Do you know it's going to come off?
Oh yeah, it says it comes off with water. So.
Off of cars.
I'm just one thing to note, Zeineb. I've done some stuff to cars before, like sprayed stuff on there, and it didn't come off like it said it would.
Uh-oh.
I remember one.
I'll try it. We'll have, when you have a skin test before you use a product, I'll do that.
Yeah,
I used to have this old Camry. It was a dark green, and one time I was washing it, and I actually waxed the hood, right?
Yeah.
But I did this really amazing job with like one circular section. That section of the hood was permanently a different color after I like it was a darker green.
Oh,
and I think it's because I had somehow buffed the scum off of the old car, but it was so much work, I couldn't do that for the whole car. So,
of course.
Yeah. Real Karate Kid moment.
Well, I mean, Nick, if it doesn't come off your core, I am sorry. I cannot help you.
There's a pre-apology that has just
A
happened.
pre-apology, yes. I'll just link him to the episode.
Oh, funny. What do you got planned for the upcoming here, Matthew?
Well, that's a good question. I think we've got a game night coming up. That should be fun.
Nice.
And I bought one of those Super Nintendos, the minis that they just came out with.
Oh, sure.
This
Wasn't there a
last
limited
year.
supply of those during Christmas?
Yeah, probably. Well, I haven't really played with it much yet.
Oh.
So maybe I'll do that.
That would be fun.
That's bound to be fun.
Absolutely. Well, thank you so much for listening. We hope you'll join us again for next week's show. Until then, so long and be well. Bye, guys.
Bye.
Bye.
All right. Well,
That was such like a sudden cause, like, don't make a noise.